Good morning, everybody. Welcome to today's INTEREST session. INTEREST is our remote engagement sessions in technology provided to you and brought to you by the ETIC, the Entrepreneurship and Technology Innovation Center at the College of Engineering and Computing Sciences. I'm Dr. Nizik. I'm the director of the ETIC, and I'm going to be your host for today's session for creating applications with Java. The concept of these INTEREST sessions is to introduce you to as many technologies that we can that are in the field in use that people are hiring for, that the salaries are very lucrative, and to give you an introduction to these technologies so that you know that they're there, you know how to get started in them, and you have the basics of how to use them, more importantly. So they're kind of a starting point for you to understand that there is a career path in these different individual technologies that's quite lucrative. And also there are very, very easy and sometimes mostly free ways to get started to build your own career path in these technologies. That being said, today's INTEREST session, creating applications with Java. Java is a programming language that's been around for a very long time, but keeps on coming out with new versions and enhancements, making it more powerful. The thing about Java that makes it so popular and still in use today after such a long time is that it's platform independent, which means that it can be used on pretty much any operating system. I believe the iOS mobile operating system is still outside of the Java platform, but other than that, pretty much anything. The Android phone app, Android Studio, is completely based on Java. Any application that you create in Java, you can create one application and release it on as many different operating systems as you want, except for the iOS mobile application at the current time. It's also a number of different versions of Java that you can use that will run on any versions of Linux. Linux operating systems run on all kinds of IoT devices and small, inefficient, not so robust applications such as cars and refrigerators and all kinds of devices that are now coming with their own embedded chip designs in them. The language Java will actually basically be able to run on those devices as well. So you can write full, robust applications with Java, but you can also have Java run on very basic and very, I'll say, low-tech devices for now, based on what they're able to do. All right, so it's one language that once you learn it, will not just give you a really, really good background in all the different things you can do with programming in general and programming languages, but you can also use it to help your career in a number of different pathways, because whether you go to a software company or whether you go to an engineering company or whether you go to an electronics company, they're most likely in any aspect of it going to be using Java in some form, JavaScript or Java itself as a language. Okay. So that is the introduction to the language itself. And let's kind of go a little bit about the ETIC. We are located in Harry Scherer Hall in room 107 at the old Westbury campus. We are a physical location, but anybody who wants to work with us remotely on different projects that we can help them with are always welcome. We have one physical location that has the ability to design and manufacture products. So if you have an entrepreneurial type spirit and thoughts of building a new product, that's kind of what we do here. So know it's available to you, know where it is, and it's open to you as students whenever you would like to engage. This is the physical kind of room that we have every ability to build these prototypes with you. And when we kind of work with students, we work with them in competitions and hackathons and different types of programs like Ursula and INTEREST, which you're in today. Ursula is our robotics program where students design original content to this robotic product that we continually build upon. We also have a process for you to start your own company, to grow your own company. We have a number of different student companies that have started and grown through here that we help out. So if you have an idea for a company or have a company already, please reach out at any time. NYIT.edu/ETIC if you want to learn more about what we do here at ETIC at New York Tech. Okay, so let's get into creating applications with Java. First of all, why do we do these INTEREST sessions? To introduce you to the technology and introduce you to a career path. Here's a quick snapshot of Indeed, 28,000 jobs, over 28,000 jobs open at the time of this snapshot that are looking for some sort of Java experience. If you look at the word senior Java developer, senior in IT, remember, doesn't mean 25 years, right? That's a different term, senior we use. Senior is 3 to 5 years. So if you get a year of programming while still in school working on projects like here at the ETIC, if we have projects going on that we need Java program, which is a ton of stuff that we do here, if you want to volunteer and work on some projects here, you can write code to the Ursula project, you can write code to our other robotic arm projects, you could do all kinds of Java work here, get your experience. That would count as 1 year. When you get your first entry level job in industry out of college, You do 2 years, and then you're at your 3 to 5 year senior level, which puts you in these salary ranges that you see in front of you. All right. So, there is again, there's so many technologies that are out there in information technology, but our job here with the interest program, or our goal here with the interest program, is to introduce individual technologies that you can really focus on, as each one could be its own career path, right? And that's why you see the ones that we offer, including Python and SQL Server and Visual Studio, right? Each one of these technologies in its own right could be its own career. So that'll give you an idea of why you're here today, and why you're willing to learn about technologies that you may or may not know about. And let's get into the content. So let's talk about programming languages in general. We have something called the C family of languages, which generally is C, C++, C#, and Java. The reason we call them C family of languages is because they use a similar syntax with the way that they structure packages and classes and methods, and the brackets and the main method, and the way they establish variables and conditionals and loops and all that. It's very, very similar. There's huge differences between the languages, but they're usually in their libraries and their packages and their references that we make to those packages. If we want to do something where we're reaching out to an internet type application, one language might do that better than the other because it has a package already in place that you can just call and access that. So the languages themselves are clearly different, which is why they're different languages. But they have the syntax on how you use the language is actually extremely similar. So once you learn one, you can adapt to the others, right? That's why a lot of programmers on their resumes will say, C, C#, C++, and Java, because it's not that terribly difficult to really move from one to the other. Okay. If we look at the top programming languages, JavaScript is the top programming language, pretty much because we want to talk about web-based application usually. And when we run scripts, by knowing Java and by being able to use the Java virtual machine, which is how Java becomes platform independent, we're able to take some of the concepts of Java that we're used to and turn them into a scripting language. But Java itself as the language is the language that we're going to create an application and be able to run it on any machine in the world, essentially. That's really the concept. A few just different discussions, only because I always find this confusing whenever we talk about languages. Remember that we have these different tiers that we develop in, right? So when we develop a one-tier application, we're developing an application where everything runs on one device. It's the data layer, the presentation layer, and the application layer that we create all runs on one device. It's kind of like a phone app, but the phone app would be updating itself off the web, but usually everything runs on one area. But two-tier means client server. We're running the application on the device, but the data resides somewhere centrally on another machine in the network. And then three-tier is when everything is on one machine, we'll call it for now. It could be multiple machines but let's just say everything's on one machine, meaning the database, the layer, the application itself, the coding, and the presentation layer, which is how people see it. But it's accessible from a browser. Many companies today are looking for individuals that can program. They're called full stack developers, and they can program in a three-tier environment. So as you think about career-wise, start thinking about how do I take what I'm learning in school and in programs like INTEREST and things like that, or even at the ETIC and projects you work on. How do we take that and become a full stack developer, right? That would be like your ultimate goal, is to become a full stack developer, because that's what a lot of people are looking for, to build these applications that are residing all in kind of one platform that people just need a browser to use. That's really where we are now, the world kind of you're getting ready to work in. So that was just this is just another example of a three-tier programming application. Okay, so without further ado, let's get into it, into the demonstration of the Java language. The one thing we want to get an idea of and learn in any language whenever we want to make the adaptation to that language, we want to learn about the IDEs, the integrated development environments that are available. In the case of Java, it's NetBeans and Eclipse. There's others, but those are the two big ones. But essentially, we want to be able to learn how to use those tools. When we work in an agile development environment, which is what companies are going to want you to know and learn, and you'll be able to demonstrate that you can work with other programmers, work with a customer, accept change in your original design, right? That's what companies want you to know today, the agile development process. And one of the components of that process is working with tools, being able to use the IDE with other programmers, right? Being able to use the IDE to manage and organize your code and things like that. We want to know the differences between packages, classes, and methods. In this case for Java, that's actually the terms that we use for that. Again, variables, conditionals, and loops, how we establish variables and the types of variables that we're using, how we break our code into classes so it's easily managed in an object-oriented programming environment. how we individually code methods that do a very specific task and process so that when something breaks, we know where to fix it. We know where to make the enhancement. We don't have to change the whole program. We can look at one different method and say, this is it. I'm only looking in this one small area. We want to look at calling methods from within the same class, right? How do we basically have a series of methods, but how do we have a main method that calls the other methods to have a hierarchical programming structure? We want to look at calling methods from another class. We want to be able to break our program into different classes, but make those methods public so that we can actually access them from different areas in different classes. We want to basically know how to send variable data that we produce in one class to another method in another class. And then also we want to be able to return data from that, right? These are some of the core things that if you've gone through any programming classes already, some of the things we try to instill in you. But on the same note, right, once the class is over, you don't always carry it with you. But this is something that everybody's looking for from a hiring perspective and a job perspective. And the other thing we want to be able to show is learning how to use data, how to manipulate data. Not so much data from a text file or data from a DAT file or even an outside database like Access or SQL Server or MySQL. Data structures, right? Stacks, queues, linked lists, binary trees. Not for this seminar, this is too short, but essentially we want to be able to show your potential employer that, I understand that I'm going to take the computer's memory and I'm going to store data from using my program and using Java. I'm going to store data in that memory, but I'm not going to access any outside program. I'm just going to use the memory of the computer to create data structures so I can store hundreds of thousands of pieces of data in these individual objects and then have them talk to each other, right? That's something that everybody wants you to know as well, right? So we'll try to do a quick demo of each one of these so you can get an idea of how that works and see it in action and understand what employers are going to look for from you as far as demonstrations of these items. Okay, so let's get started with the demo. So the first thing you'll see is that we're in something called NetBeans. NetBeans is an IDE integrated development environment. This particular program will allow you to create new projects. And when you create new projects, you can choose from different types of Java-based projects, okay? If you're building a Java program that's going to run off of a file server on a web server and you want people to run it on their local machines, you can build that project. If you want to build a project that people are going to run on individual machines off of a USB drive, or you can do an install off of an installation program to run on the laptop or the desktop or the Mac. Again, one application, once you write it, it's going to run on every single operating system, which is kind of amazing if you think about it. But it's what's really made it so popular. Usually what will happen is if you're building an application for multiple operating systems, you have to create one for Windows, one for Linux, one for Android, one for iOS, right? You have to create the application 4 or 5 different times. It becomes a bear to really manage, and you get an upgrade on one and not the other, and it's troublesome. From a business perspective, Java allows us to kind of get around some of that by creating the application once and releasing it for different platforms. Okay, so as you create new projects, you can choose which one you want to work with and design. What we're going to work with today is a package that we call Method Demo. It's just something that we created. We actually use it for our data structures class. So it's something that we use just to demonstrate certain things that we want to show you today. So basically, whenever you have a package, that package gets a name. A package allows in Java, a package allows you to create all different classes with certain names inside that package. If I have multiple packages, I can have classes with the same name inside that package because it's in a different package. They're two different worlds, but they can talk to each other. We can access things from one package into another package, right? But it gives us a great way to organize. If I'm building one application and it has finance applications, it has accounting applications, it has human resource applications, and it has warehouse and supply chain applications, I might want to have 4 different packages because some of the class names in each of those packages are going to be the same, right? You're going to have persons or names. You're going to have orders, order details. You don't want to create different names for classes just because you have different areas of the business, right? So we want to be able to have ways to organize that. Packages allow us to do that. And with Java, by having one project with multiple packages and multiple classes inside of those packages, we're able to really create a nice structured organization. Oh, we've got a bug that happens in finance while creating the tax calculation. Okay, we know what package it's in, we know what class it's in. Now we have to find the method, but that's what we'll do next. We'll show you how that breaks out as well, right? So this way of working in IDs allows you to create these projects, but also with these individual packages underneath. So first thing is that we usually have some sort of a main class, right? Each one of these are considered a class. In object-oriented programming, we consider a class an entity that we use that's going to be able to instantiate objects. objects are going to be individual units that we can make one object talk to the other and transfer information between the other. And they have attributes and they have behaviors, they have all kinds of things we talk about as far as objects. But once an object exists, it exists in memory, and we can then keep it out there and never use it, or we can keep it out there and use it when we want, or we can keep it out there and use it all the time. But once we create an object, we can actually interact with it. So it's a really neat way to kind of think about, instead of line by line programming and just very, very dry, think about kind of an explosive view of, right, of your, if you think about the universe breaking out, we have all these different objects that we can just access as long as we want. And we have names and we have ways of manipulating those objects. So, so in this case, let's just look at the output first. It'd be an easier way to look at the output of this particular program, okay? So you'll notice that our website Ursula is popping up when we run the Java program. That's very strange. It's not so strange, and we're going to see that in a second why that does that. But when I run the program, our Ursula website comes up. Okay, that means we're making a web call as part of this process. But here's what our results really are down in the results window. It states this is how to call a method again. This is how to call an external method again. This is the compound interest is this number. Web page opened in browser, Friday, the amount returned from the method is all these outputs that come out from our program. We don't know why they're coming out. Well, we're going to show you, because what happens is that what I showed you in the beginning of the seminar, all these things we wanted to know about calling classes and methods and things like that, we're going to see how that works in this program, right? And it's a neat way to kind of put it all together and do the demonstration for you. So if we look at our main class, now we called it main, but it could be called anything you want. One of the things it has in it that the others don't is a main method, okay? Anytime we see an initiation of a method, in this case, we have something called static void internal method. The name of the method is not so important. It's a way to identify. It is important, but it's a way to identify. But we can really name it anything we want. But the main method is really how Java understands where to start. So we kind of do have to incorporate that method. Anything else, we can pretty much name whatever we want. But in this case, with the main method, what we're doing is we have a series. It's not that long. Again, in C, C++, C#, the instantiation of a class, of a method using these brackets and setting them up as public or private. These things are very similar in languages. So once you learn the syntax and once you learn one, it's not so difficult or really so different to learn the others, which is why we call them the C family of languages. But if you look here, we're getting a lot of output here for not so much code, right? Well, how's that possible? Well, because we're calling methods in other classes that are doing all the work. We call this information hiding or abstraction, right? We're going to call the method that's running in another class, and it's going to do the work we want to do. And it could be enormous. It's not for this demo, but it could be enormous amounts of work. But we're not going to see it in our main method. We call it information hiding. Our brains wouldn't be able to process it if we saw everything in one big chunk of code. It used to be like that. We used to call it spaghetti code in industry years ago. Unfortunately, I remember. But basically, we would have programs that had go-to statements. You'd finish one area and go to the next, and you had to do all these kinds of things. But it was one big, giant program. You'd have thousands of lines of code sometimes in one program, and it would be like you had to kind of figure out which line number went to which line number, and it was really, really frustrating, and your brain would just explode sometimes. And here we have different classes and object-oriented programming, which has been out for years and years and years, but like it's a replacement for that original coding process I talked about. We have ways of organizing our code so it's not so crazy. Here I can see, all right, this is what's happening. I'm not running a real big program here, but behind the scenes you can see that there could be massive amounts of code behind the scenes, but we're not really seeing that. Right? So let's look at the first line. It says it outputs, this is how to call a method again, right? So this first line right here, internal method with the open brackets and closed brackets, all right? We're not sending any information into the method. We're just making it run. So whatever is programmed to run inside this method, notice how we end it with a semicolon. That's how the compiler realizes, this is the end of a line, whatever I'm supposed to do, run it, right? So we have, again, syntax is going to be the same, C++, C#, Java, all the same syntax. So if we look at this particular method, this is going to be inside the same class because I'm not identifying it with a class name. If you notice this next one, external class dot external method, that's a class name with a method inside of it. So that's a whole different class. Notice over here we have an external class, right? We have the name external class, but it's a different class. So there's methods in there, and there's methods in the next one, and so forth, and that's how we reference them. Here, we're referencing something called internal method, but it's clearly inside of the same class because we're not referencing a class dot method, okay? pretty, I won't say simple, if in case you haven't seen this before, and I don't want to make it sound like that, but it is. Basically, we're just saying, let's call a method inside of a class. So now what we do, this is our main method, but let's look for another method called internal method. Oh, there it is. It's a static void internal method. We're not expecting anything back, which is where the void comes from. And we're just saying, whenever somebody calls this method in any fashion, we're going to output system.out.println. We're going to output this comment, okay? If I wanted to say again, and I wanted to put 2, okay, the number 2 there, and I run the program, my first line, there's my pop-up. I'll explain why that's happening in a second. But my first line now changes to, this is how to call a method again 2, right? So by calling internal method here, it's actually it's running whatever's in this internal method. Now it's so simple, I'm just outputting one line. But what if this was a massive compilation of some sort of algebraic equation, right? It would still run that, and then the way that you would call that and want that algebraic expression to run would be just simply to do this again. So right now, the reason it's printing out is because I've only got a program to print out a line for the demonstration, but you could have it run any kind of massive code you want inside that, and as soon as you call it, that'll happen. Now, you could imagine that if we had a bunch of methods inside of a single class that were highly complicated, that we may get really messy, right? Your brain might explode eventually looking at all this code through all these different methods in a single class. And if they're really truly different from a domain perspective, if you're really dealing with an interest calculation, if you're really dealing with a financial calculation, if you're really dealing with a human resource type processing, but you don't want to incorporate all those together in the same class. They have nothing to do with each other, right? You want to have an interest class, you want to have a finance class, you want to have a warehousing class, you want to have a human resource class. And in that class is everything to do with human resources. Maybe you do some sort of evaluation off of a resume. Maybe you do some sort of a financial calculation off of an interest rate. Maybe you do some sort of tax calculation off of the state and zip code. But they're so different, you wouldn't dream of keeping them all in one chunky class, which is a lot of times what we do just in practice and demonstration, things like that. We keep them all in one big area. And that's really not what you would do in a real development environment. What you would do in a development environment is you would think about, and you would branch out, and you'd plan out all your different classes based on what your program is going to do, and you would clearly structure them so that if you got a bug one day and that bug was in the tax calculation, you would say, great, I'm not going to look in anywhere else but the tax class, and inside the tax class I'm going to look for the method that actually is causing the bug. Okay, so that's kind of like what we try to do with the organization and the hierarchical structure of these projects. So the next thing based on that is the fact that we're going to call another method from another class. So if we were to open, we're in the main class right now, but if we would open the external class, it's a separate file that's inside, right? That's inside the project. And inside the external class, we have a method called external method, and we have another output, right? That we're going to say, external method again. Notice that there's no main class here, no main method here, excuse me. Why is there no main method here? Because we don't want the Java program to start here. We want the Java program to start at the main class and then the main method, okay? So the main class is always identified by any class that has the main method. You'll notice a little play button here on the class called main here. That's because there's a main method inside of there. That's how the Java program knows where to start, where you want it to start. All these other classes, we want to be public so that we can actually see public. Public makes it so that you can see all the other methods from other classes. Once we do that, and you identify the package in each class so that it knows it's part of the same package, right? That's how they all are able to talk to each other. So once you do that, now you have the freedom to really, really break out your thoughts and say, no, that's in, say, an automotive program. No, that's a timing belt issue that's going to come into this other maintenance type program. So keep it all in a maintenance class. Keep the sale of the automotive vehicle in a sales class. Keep anything to do with anything, you want to break it out so that you're not looking all over for it, and then one thing doesn't have another thing to do with the other, and it gets very, very frustrating to try to fix things once you've identified a bug, if it's not broken out into these types of hierarchies, okay? So what you'll see is when we run the program, what's really happening is that in the main method, the external class dot external method is being run, not being run with any parameters. We're not sending it any data yet. because we have a blank inside the parentheses, but we are sending it, we are calling it so it will run, okay? The next thing we have to show is that we're just doing simple outputs and print jobs here, right? But we want to show that you can do other stuff with Java, obviously. So just as an example, if we look at the calculate interest class, the calculate interest class actually has a interest calc method inside of it. That, again, not very complex, but it shows you that you can do anything you want in here. If you wanted to have any sort of complicated type structure or process in here that would really do something that would truly, why do we use computers? We use computers because it would take us too long to do things by hand. It would take us too long as humans to do it. So we write things to automate that process so we don't have to do it anymore, right? That's why we use computers. So you would create something that would be way too hard to do, via our own abilities, and that would be what you'd be running from here. Okay? And what you'll notice is that in our output, this particular calculation that we do here, notice that we're using a variable called principal, and we're establishing that variable as a numeric type, but even more so a double numeric type, so we're able to show decimal points, okay? If we just use an integer, it has to be a whole number, and if we use a string, it has to be text. It can't have numbers at all. So we always, whenever we're going to do calculations, we always use numeric variables, but we also use certain types that we want to basically be able to show. So in this case, we're showing how you instantiate, right, a variable, and you basically call it principal. Now, once principal exists, we can do anything we want principal. And here we're increasing it to an exponent using the math.pow function. Okay, so now we're outputting. You can see the value that gets outputted here is doing the calculation for us without actually having to do it. But we're calling that method that does that from one class from another class. It allows us to think about a very structured design for our software. Okay, let's go back to the main class. And let's take a look at what's happening next. What is happening here? We have a class, we have a method inside that class, but now we're sending that method variables. We're sending that method variables to read in and do something with. So now we're not just calling that method and having it run. Now we're calling that method and we're sending it information. That's pretty cool. Now we can start gathering information from a user. Now we can start gathering information from another outside text file or something like that, or some other log file. Now we can gather information and now send it to another class with another method that's really uniquely, right, kind of structured, that does a very specific task. And now it's going to process it off of information we give it. Now we might should be clicking here and saying, now I get why computers are so powerful as far as being able to send it this different information every time. Okay, that's why we call them variables. And if we look at that, if we look at the parameter method, this parameter method here is yet a new class. And if you notice what we're doing a couple of things here. We're starting to import things. We haven't imported yet. Well, import is when we bring in a package that somebody else wrote that's part of Java. It's been verified by the open source community and said, yes, this is going to be part of Java from now on. So the next release of Java, whatever version that is, this package that does this really useful thing is going to be part of Java, and everybody's going to benefit from it. So now we have a package called java.net.uri, which allows us to deal with websites and do web calls. Now we're able to basically reach out to a website and do something. We can call a website and insert data into a web portal. We can do a post, do a get, we can do a read, we can collect information off a website. Whoa, now we're getting a little bit more in depth. And there's thousands and thousands of packages that we can import and do different things with. Okay, that's what makes these languages, C, C++, C#, Java, it makes them so powerful because every new version that comes out, there's 100 packages that other people have written that are really useful that are now incorporated into that programming language, which once we upgrade to that, we're able to use that. But let's take a look at this method, right? So this parameter method, instead of just having parameter calc and an open paren, close paren, now we're saying, what are we looking for from the class and the method that is calling me? What are we looking to receive? We're looking for an integer, an integer, an integer, and a string, right? We're looking for, right, 3 integers and a string. So it could be 6, 2, 5, hello, or 500, 200, 300, and goodbye, right? It doesn't matter, but it allows that class and that method to send variable information that changes every time into this class. Now this class, once it reads it in, it assigns variables. It assigns them to A, B, C, and D. So once you call this method from another class, from another method, and you send it data, that raw data becomes a variable in here. It doesn't care what it is. It just cares that it knows what it is and how to reference it. So now it's referencing it as A, B, C, and D. If you look, we have things called right motor, left motor, speech, duration, EURL. We have a robotics project here called Ursula. And it allows students like yourselves that when you say, look, I want to learn Java, but I want to apply it, Ursula is your tool. You can write Java code on your laptops at home, in your classes, wherever you are. When you run it from wherever you are, it'll control our robot in the lab. Okay, you can kind of Google Ursula and take a look at the Ursula website if you want as part of a different seminar, but you can kind of research that. But what it does is it allows students like yourselves to learn Java through the Interest program, practice it, but then apply it onto the Ursula robotic project, which then you actually get to see your code in action and having a difference. And here what we're doing is we're actually calling the right motor values, the left motor values, the speech as far as what we want her to say, how long we want her to run for. So if you wanted her to go straight or turn left or turn right or whatever you wanted to do, this particular program, we're sending data into this. And then once we process it, now this EURL, this string EURL, now we're calling an API, which we wrote with C#. So again, if you want to learn C#, we write code in C# for the Ursula project. This particular API, now we're sending information using what we know is in this URI package. So now we know that we're able to actually call, right? We're actually able to call this URI object and send to our API on the website. That's why the web portal is popping up, because Java, if it was run on any machine in the world on a local laptop, it would call the centralized website that's open to the global community. Right? So it gets really cool really fast to be like, oh my goodness, this is why coding is so much fun and so powerful, is because I can make these types of changes with all these packages that I can work with. So now we have a demonstration of a method importing information that's given to it and doing something with it, with that specific information. Okay, that's another piece we talked about. You would need to learn with any language that you want to navigate into, transition into. Now, one of the things that we want to be able to do is we want to be able to send information into a class, into a method, into another class, variables that we collect from a user, or we come up with some from a process of our own locally in our own class. We want to send it to that other class. We want it to process it, and we want it to give us back the result, right? That's when it gets really exciting, because now we're like, all right, I've structured my project and my class is really organized, and each one is doing its own thing. But now between them, you're sending the information that you have from one to another, and it's giving you back the result, and it becomes just a great clean-cut way to program and develop applications. As an example, if you said that you're going to collect 3 numbers from a user and you're going to add them together, sounds really simple. You'd probably do it in the same class. And yeah, I get it, but think about it. The more complex the requests become for those 3 numbers, now we want to do an exponent. Now we want to do some other algebraic expression, things like that. Now it becomes a mess. You've got one program collecting user data. You have the same program processing the mathematical components of it. It becomes confusing. The better way to do it would be to collect the information from the user, send those variables into another method that's going to grow and do all kinds of complicated stuff with those same 3 numbers. But then whatever it comes up with, boop, it's just going to send it back to you, right? So we want to send information into a method, but then just get that number back. So if you look at what we're doing here, in return method, return amount, all right, what you'll see is that we have a return method. Again, no main method, sorry. We have a return method that is, it's instantiating a variable. It's called double. It's called return amount, but it's a double type. And we're looking for, so return amount is looking for 2 integer values and 2 double values, looking for 4 numeric values, but 2 are going to be integers and 2 are going to be decimal values. Don't have to be, but they could handle it. Then what we're going to do is we're going to set another variable called total. Total is a double. It's going to handle decimal values, but total is equal to the sum of all three of these values that could change at any time from one method to another, okay? So in this example, the variable total becomes the value, the sum of those four variables that we just read in. So numeric variables, it becomes that. Maybe it's 11, maybe it's 12, maybe it's 5,250, whatever that number is. But by using the keyword return, and then the variable that we know is the variable, the program that we call it from is automatically going to know to look for that return value. That's how simple it is. So if we call this method inside this class and we send it the right integers and the right double values into it, 1, 2, 3, 4, A, B, C, D, if we do that right, this program is going to read it and calculate it, and then it's only going to return to us the value that we're looking for. So depending on how complex this gets, think about it. This could be GPS calculations. This could be all kinds of crazy complex stuff that you keep in a separate class, in a separate method that's easy to locate and identify and fix when you need to, or when you need to enhance it, right? And all the other stuff that's working beautifully, you don't have to touch. So you're not risking breaking 3 or 4 different areas when you're trying to fix a bug. Okay, so one thing I wanted to kind of point out to you is that when I keep talking about bugs, right? When you're in industry and you're working and a bug is found and say it's affecting 600 clients, it is priority 1 to fix and release those patches. All of your customers that pay you money are experiencing these difficulties with this bug, all right? So the last thing you want to be doing to fix a bug in a pressure situation, to get it out in the next 2 hours because people are crashing all around with this latest release, you don't want to be looking for where that bug is happening. You want to know if the bug has been identified to be happening in the tax class of the tax calc method. That's all we're working in. Keep everything else the same. Fix that one area, then recompile and send out, in this case, the jar file to the customers, okay? So that's why I keep talking about easily identifying and easily finding your code in these different classes and methods, because that's how it is in industry. Pressure cooker, you just launched this application, you're trying to charge people extra money for this upgrade, and it doesn't work, and you got to fix it fast. You don't want to be in that situation where you can't find where you did the code. Okay, so let's go back to the main method, the main class and the main method here. And you notice that we're doing this return method, return amount. We're sending in, we're calling this return amount method from the return method class with these particular values, 5, 3, 5, 6, 7, 8, and 89. What we're getting is the total summed up by the total. And the reason we can print it out here, is because that class, that method in that class is returning that value to us, and we're outputting it, okay? So that gives you a really good, concise demonstration of all the things we want to be able to do in any programming language, okay? Especially organizing your coding in a certain hierarchical format so that we can use these different classes and these different objects and these different methods inside of there to interact with each other, right? We don't want to write things 5 and 6 and 7 and 8 and 100 times over and then have bugs in each one. We want to write it once, and we want to make it available to all the other classes and applications and methods to use. That's quality software. That's what we strive to do. Not that we do it all the time, sometimes we got to do these quick and dirty fixes, but on the same note, that's what we strive to do. That should be your goal in everything you do. Okay, there's one thing here that's menu class.run menu. So let's take a look at that. Okay, one of the things that we want to be able to do here is we want to be able to work with menus. I've chosen to use this case functionality for you. So if you create an application, many times you have to actually use input from the user. So you use something called the scanner class, which we're not going to be doing in this demo, but you can use that to capture integer string information from a user. When they enter that, you can store it to a variable and then use it. What I wanted to show you here is that notice that we're printing out Friday as part of our results. And notice that Friday here is case 5. Case is a keyword that we use in Java to establish, rather than use a conditional of if then, it gets a little messy, if then, and then. And sometimes it gets really, it doesn't always work either when you have more than 2 options, when you have more than a binary situation where it's this or that. You call them if else's, right? If then this, then this, the else do this. Once you get to the second else, how does it really know? How how does it really know that you want one or the other? So it gets a little messy, but case fixes that in Java. Case just says, look, if this is your case, if this is your case, you could have 5,000 different cases that it's this or that, right? And it still does what you want it to do, all right? So we're just outputting a number here, but if you think about the complexity of this, you could say case 5, yeah, we're putting out Friday, we're printing Friday in our result. You could be calling with variables one of your methods from another class that's super complex as far as the interest calculation or financial calculation. Maybe it's an amortization of a mortgage or some other interest, long-term interest rate, something that you really don't want to be doing twice. And your case could simply call that with some variables and then return the value. So, you know, when you put all these together and you start thinking of a problem that you're trying to solve with software, these are all the components that companies want to see that you have an awareness of. That yes, I need to do menus for user input. Yes, I need to do case structures to call certain methods in other classes that do certain calculations or certain complexities and then return values to me. They want to see that you have a grasp on all this stuff so that you can show how you can benefit their organization the most. Okay, so one of the things that we talked about in the beginning of the different topics you want to be able to show that you know kind of how to work with in any language, it was data structures. And when we talk about data structures, I mentioned in the beginning, we're not really talking about text files and access databases or paradox databases or any kind of like simple local database. We're talking about internal memory. We're talking about manipulating the internal memory of the computer to store data that you're collecting from a user or that you're processing. Usually in any complex mathematical calculation, you can't really just calculate it all in one fell swoop. You have to kind of do step 1, then step 2, then step 3. And whatever the result of step 1 is, goes into step 2, right? We call it iteration, different types of things that we need to do when we're doing these complex calculations, right? We have to take the result of one step and insert it into the next step, and then we insert it into the next step and so forth. So we don't have the ability to write a program that's going to just zip through and be like 1 to 50 steps and do it. We have to take the result of one and store it to another. We do that we store those things through data structures. We create an object in memory called a data structure, and depending on what type of data structure we use, the items that we store in that structure are going to be accessible in a certain format. I chose to show you a stack today. A stack is a LIFO, L-I-F-O, last in, first out structure. The stack allows you to access data. You can store as many pieces of data in the stack as you want, but it only allows you to access the top item, the very last item put in, okay? It works in computer science. We use it for processing. If we're talking to process, we're trying to do threading or dual or multi-processing. We have one processor trying to do 2 things at once. We create stacks with all the different instructions, and then we go from one to the next, the next, the next, the next. And it seems like we're doing it at the same time, but really it's one or the other. But the stack holds all these instructions for both processes we're trying to do, and we're just going, we're just going one at a time. And it seems like it's happening at the same time, but they're really just, you know, fractions of a second different because we're going from one data structure to another. In that case, a stack. That's why you see many times in your program errors, you get stack overflow errors because the stack wasn't configured properly. You tried to insert something into a stack that was full, or you tried to take something out of a stack that was empty, and you get these stack overflow, underflow errors, and that's really what they are. The beauty of data structures is that they're memory based. They're not an external text file. They're not external to the program. So when you create one program and it becomes a jar file or an EXE, if you're dealing with any other kind of programming language, they're just memory. They're not, you're dealing with hundreds of pieces of data from all kinds of sources, but you're not dealing with a database. You're just dealing with memory in the computer. So basically what we do in a very simple demo here, what we do is we import in our external package that allows us to work with a stack. They don't become naturally. So you would either have to do star or .stack, which I believe it is a stack. So you have to import in either .star, which is all the different packages at once, but that could be memory intensive once you release it, or you could just bring in the one you want. So in this case, we're just working with a stack, so we could bring that particular package in. Now that package has methods inside of it that allow us to store data, but it's information on it. We don't need to know what it's doing. You might want to, but you don't need to, right? You just want to be able to use a stack and manipulate it. We use these things called constructors and transformers. We build the stack and create an object, and then we transform the stack by adding data into it. And they're very simple to interact with. It's not so simple as far as what's happening behind the scenes, but they are simple to interact with. So what we do is we basically create, in our main method here, we've done it all in one method just for the demo. But essentially, once we import in stack, we can now reference stack. We can call it, right? We can call it a certain name. You can call it whatever, you can call it interest 2 or something like that, whatever your stack is. And we establish it as a new stack structure, okay? So now we have this object. As soon as we do this piece, that's the constructor, boom, it sits in memory. It's out there for us to move from different classes. As long as the program is running, that memory is allocated and that stack is in memory, and we can put stuff into it. We can take stuff out of it. It always stays active until we decide not to have it active. And we have these transformers. In this case, we use push. Pop is the constructor to basically remove stuff from the stack. But when we push stuff in, we're adding it to the stack. So when you run this program, you can see that we are basically adding all these elements into a memory structure that's nowhere on the hard drive. It's part of your memory. There's no physical file on your hard drive that would store this data like a normal database like you might be used to thinking. This is a memory-based data structure. So all this data is sitting out there and is structured and organized, and you can only access the top one. But essentially, when we pop the item, it's showing us the stack is full of data, but when we pop, we're really removing the item. So we're really only showing the items that are remaining in the stack. Whenever you have the need or ability in Java to write your program and then manipulate data that's being accessed from some calculation you're trying to do or some user input that you're trying to do, there's all these different data structures that you can use, right? Stack is one of them, last in, first out. Queue is another one, first in, first out, reversed. You have linked lists, you have arrays, array lists, you have binary trees, you have heaps and heap sorts and graphs, right? You have all these different structures that are designed for very specific purposes to handle straightforward small amounts of data that you're just going to rip through and do your process with, to massive amounts of data that you need to search really quickly, to data that you need to find the shortest path from one point in the data to the other. There's all kinds of things you can do with these data structures. That's another thing that employers are going to want to know that you have some awareness of and can show in some respect that you're manipulating these structures. So with that, we are at our finish time for the interest session. I'm going to stop the recording and we can do a little bit of a Q&A. Thank you for attending, and I look forward to seeing you at our future sessions coming up for interest at the Entrepreneurship and Technology Innovation Center at the College of Engineering and Computing Sciences.